All right, so welcome to our second video in Unit 1, which is all about the percent composition of an element in a compound. And this is very simple, actually, because if you think of a percentage of something, it's just what is the percentage of the item in question over the whole, right? So if you get a 90% on a test, that means that you got 90% correct out of the 100% that was available. So we can do the same thing with elements in compounds, and that's what we call determining the percent composition. And there's really two ways to determine the percentage of elements in a compound. And the first way is by counting the number of atoms in the molecule. Which, of course, if we're doing this and we actually have a compound and we're experimentally trying to determine this out, this is very difficult. So chemists don't usually just count the number of atoms in the molecule, but what they can do is by actually calculating. Make this bold and red so it stands out a little bit. But by calculating the percent composition or the percentage by mass, or you might even see mass percent. I'll say or mass percent. They all mean the same thing. Of an element in a compound. So we can calculate the percent composition of an element in a compound using a very simple equation. And like we said, the percentage is just how much of the whole. So if I want to know what's the percent composition of an element in a total compound, I'm going to take the total mass of just that element in the compound. I'm going to divide it by the molar mass of that compound, which would be the whole, and I'm going to multiply that by 100. So I think it's easier to actually do these than it is to talk about how to do them. So let's go ahead and try sample problem 3 together. Let's get our draw function back out here. So it says carbone is a substance that occurs in two forms having different arrangements of the atoms, but they have the same molecular formula and mass. One type of carbone gives caraway seeds their characteristic smell, and the other type is responsible for the smell of spearmint oil. So that's pretty cool. Calculate the mass percent of each element in carbone. So I want to know what's the mass percent of carbon in carbone, what's the mass percent of hydrogen in carbone, and what's the mass percent of oxygen in carbone. So what I like to do first, and I break this down like quite a lot, but I think that it actually makes it easier in the end. So I'm going to just find the molar mass for this compound first, that very long drawn out way. So if you remember from Chem 1, I usually like to set up my list of elements here, and then I go from there. So I'm going to start off with carbon, and carbon's molar mass is 12.01. And carbone contains 10 carbons in this compound. So I'm going to multiply carbon's molar mass by 10, and I get 120.1 grams per mole. So of this whole compound, 120.1 grams of the total molar mass comes from carbon. Hydrogen's molar mass is 1.01. And there are 14 hydrogens in this compound, so I'll multiply that by 14. And I get 14.14 grams per mole. Oxygen's molar mass is 16. I'm going to multiply that by 1, of course, because there's only one oxygen in carbone, and I get 16. I like to do it this way because in order to find the mass percent, you need these numbers. So I like to write them down because I don't want to have to calculate them again. So I'm just going to add all of these up to get the total molar mass, and it's 150.24 grams per mole. So this right here is the total molar mass. I'll just put MM, total molar mass. If you do that, you have every single value you need to calculate the percent or the percent composition for every element. So let's go ahead and determine what's the percentage of carbon in Carvone. I'm going to take the mass of just carbon in this sample, which is 120.1 grams per mole. And I'm going to divide that by the total molar mass, which is 150.24 grams per mole. So it's the element in question divided by the total. And I'm going to multiply that multiply that by 100, because of course it's a percent. And I get 79.94%. So this particular compound, Carvone, is 79.94% carbon. Let's go ahead and do the same thing for hydrogen. So I'll do percent of hydrogen next. I'm going to take the mass of hydrogen in question, the total mass of hydrogen. So 14.14 grams per mole of Carvone comes from hydrogen. And the total molar mass is still 150.24. And I'm going to multiply that by 100 again. And I get 9.412%. Notice I am following significant figure rules. 4 sig figs, 4 sig figs, 4. So by mass, 79.94% of Carvone is carbon and 9.412% is hydrogen. Now, you can do the 16 over the 150 to get the percentage of oxygen, but we know that the total percents has to equal 100. So I'm just going to do this 100 because I know the total has to be 100, and there's only one element left, right? So if the total has to be 100, and if I subtract from that the 79.94% of carbon, and I subtract from that the 9.412 percentage of hydrogen, because there's only oxygen left, that should give me the remaining percentage oxygen. So let's just calculate this quick here. So 100 minus 79.94 minus 9.412. Following significant figure rules, looks like 2 places after the decimal. Looks like the remaining 10.65% is going to be oxygen. And that's percent composition. It's just the percentage of the whole. And I was able to do that last part, of course, because that was the remaining element that was there. If you did 16 divided by 150.24 times 100, you should get the same exact value. But it is important to know that all the percent should add up to 100. Let's try sample problem 4 next. So penicillin, the first of a now large number of antibiotics, was discovered accidentally by the Scottish bacteriologist Alexander Fleming in 1928, but he was never able to isolate it as a pure compound. This and similar antibiotics have saved millions of lives that might have been lost to infections. It has a formula of that right there. It's very long. We want to know what's the percent by mass of just nitrogen. So let's go ahead and do that whole long drawn out system here. So I'm just going to list all of my elements first, and I'm going to write their molar masses. Oops, 12.01. Okay, so I just listed all of the elements in penicillin F. And I'm just going to multiply each molar mass by how many of that element is present in the compound. So it looks like there are 14 carbons. So I'm going to multiply this guy by 14, and I get 168.14. As far as I am concerned or know, grams per mole and AMU are kind of used interchangeably. I think AMU is used more for like singular atoms, like one atom that's listed, whereas grams per mole is more for like a given large sample of atoms. But I like to use grams per mole when I'm working with molar mass, but you might see AMU there as well. I think AMU is less commonly used, but anyway, just a little side note there. 20 hydrogens. Looks like there's 2 nitrogens, so I'll multiply that guy by 2. Sulfur, just 1, so I get the same thing there. I want you guys to get very comfortable keeping your units as well. So we want to write these out as explicitly as we can so we don't get units lost. You're going to see as we progress through AP chemistry, it's very easy to lose track of units. So we want to write everything out very in depth, very neatly, so we could follow our work. Add all these up, and I get 312.43 grams per mole. So that's the total molar mass for penicillin. We want to know what's the percent composition of nitrogen. So lucky for us, we don't have to do the whole entire thing. But let's just take that percentage of nitrogen. So just the 28.02 grams per mole of nitrogen in the compound. And I'm going to divide that by the total. The total is 312.43 grams per mole. Times that by 100. And when you do that, you get a pretty small amount, but significant enough, and it's 8.968 percentage by mass of nitrogen. And that's percent composition. Very simple, self-explanatory. The only way it would get more difficult than this is if you're kind of comparing percent compositions, but you could do that if you could do this, and we'll get more practice with that in class. Let me know if you have any questions in class the next time I see you, and I will see you in the next video about determining the formula of a compound. Bye.